Okay, now that you are masters of the ionic bond, let's discuss our other main type of bond, for this class anyway, covalent bond. Now, you can probably figure out what this type of bond is, how it works, just by looking at the word. What does the prefix co mean? It means to share, and valent. That kind of sounds like valence, right? The outermost energy level, valence electrons. So these are bonds formed from the sharing of valence electrons. Now already that is different from an ionic bond because we saw last time, I hope that you remember, that an ionic bond involves the transfer of valence electrons to form ions. Sodium completely lost the electron to form a positive cation. Chlorine completely gained it to form a negative anion. But that is not what is happening here. Here, the electrons are not being lost or gained, they're being shared. Typically, so that all atoms in the system achieve an octet, or a stable arrangement. Once again, why do bonds form at all? Because systems in nature will always seek the lowest possible potential energy state, and that's what the bond represents. Here's the simplest example I can give you, hydrogen. Hydrogen has one electron. Hydrogen, unlike most other atoms, does not actually want an octet. It doesn't even have access to an octet. Hydrogen is in the first period, the first energy level, which can only hold 2 electrons. So hydrogen would be happy to be like this noble gas, helium, with only 2 electrons. It's not until we get over here that elements really start wanting to have an octet, like neon and so forth. Hydrogen would be happy with 2 valence electrons. So let's imagine that we have 2 hydrogen atoms close together. What could they both do to become stable and happy, to reach a potential energy minimum? They could share their valence electrons. So you can see that right here we have, here's this hydrogen atom, and here's this hydrogen atom. And right in the middle, this hydrogen atom has brought his electron to the party. This hydrogen atom has brought his electron to the party. And they're sharing them. By sharing, they both have 2 electrons. And they're both stable and happy. What actually holds the atoms together? Well, once again, it is the idea that by reaching an octet, or in hydrogen's case, 2 valence electrons, by sharing and by doing that, they're both stable at a potential energy minimum. But also, there's attractive forces involved. 2 electrons are in the middle here. The electrons are kind of stuck in the middle, and they are at the same time attracted to the nuclei of both atoms. Remember, the nuclei are positively charged, dense regions of protons and neutrons in the center of an atom. So positive and negative attract. Positive and negative attract. So this system is held together, and we have a chemical bond. It's called a covalent bond. It results from the sharing of valence electrons, and it will always be the sharing of at least one pair of valence electrons. We will never see atoms sharing only one single valence electron. And you know that ionic compounds, like this, formed a big crystal lattice, and it was typically between metal cations, this was sodium, and non-metal anions, chlorine, positive and negatively charged ions, because they've transferred electrons. Not so with covalent bonds. They're sharing valence electrons, sharing pairs of them to reach stability, and it's always going to be between only nonmetals. Hydrogen is a nonmetal. This hydrogen, of course, also a nonmetal. So purely nonmetals here. Covalent compounds formed between nonmetals involve sharing of pairs of valence electrons. You know that already. Really important distinction between covalent compounds and ionic compounds. Do you remember the structure that ionic compounds made? Yeah, they made big crystal lattices, right? Formed from cations and anions. Here, covalent bonds form distinct units of bonded atoms that we call molecules. So let's look at this slide. This on the left is what a metal and a nonmetal would do. Lithium and chlorine. Lithium, these lithium atoms, have completely given up their valence electrons. Chlorine has completely gained them. Lithium is left with a positive charge, chlorine with a negative charge. We have a metal and a nonmetal. We have a metal cation, nonmetal anion. Of course, they're going to attract each other. And this happens to large numbers of these to form a crystal lattice. Not so with covalent compounds. Here, this is an example of water, H2O. Hydrogen is a nonmetal, oxygen is a nonmetal, so we know it's going to be covalent. And you can see that this covalent compound forms these distinct units that we call molecules. So this is a water molecule, 2 hydrogens, H, stuck to 1 oxygen in the middle, H2O. Here's another one, that's a molecule, and here's a molecule. So covalent compounds hold atoms together in these small, distinct units called molecules, not a big overall crystal lattice that could repeat forever, but individual units called molecules. How, by the way, does water become liquid? Well, do you remember intermolecular forces? These water molecules, in between them, would have weaker attractive forces, right? Something to keep in mind. And typically, covalent compounds are liquid or gaseous at room temperature. Here's just an example of a covalent compound called methane, CH4. Here is a chemical formula, right? Do you remember what the chemical formula, for example, Al2O3 of an ionic substance represented? How do we know this is ionic, by the way? Well, we have a metal and we have a nonmetal, so of course it's going to be ionic. This is a compound between aluminum 3+ ions and oxygen 2- ions. What did these subscripts in this formula represent? The ratio of atoms, the ratio of ions within the crystal lattice, correct? Here's sodium chloride. What's the formula for it? NaCl. Remember the invisible ones here? What do those represent? The ratio. For every 1 sodium, there's 1 chlorine ion. That's what the formula means for ionic compounds. It is not that way for covalent compounds. For covalent compounds, the formula actually tells you the actual number of atoms in the molecule, CH4. These are both nonmetals, so I know right away this is going to be a covalent substance. And I know that the covalent substance actually has 1 carbon atom, and it actually has 4 hydrogen atoms to make this molecule right here, CH4. How are those atoms held together? By the sharing of valence electron pairs. You can see, by the way, that whenever atoms share valence electron pairs like this, remember why are they doing this? So they're trying to become stable to reach an octet, or in hydrogen's case, to reach 2. So hydrogen, each hydrogen brings 1 valence electron. Each carbon brings 4 valence electrons. You can figure that out by looking on the periodic table. And by sharing them, you can see that this hydrogen has 2 electrons. This hydrogen has 2 electrons. This hydrogen, indeed, has 2 electrons. This one has 2 electrons. So those hydrogens are happy. What about the chlorine atom? What about the carbon atom in the middle? Is it happy and stable? Does it have an octet? Has it reached a potential energy minimum? Indeed it has. 2, 4, 6, 8. By sharing with 4 hydrogen atoms, each hydrogen has brought 1. Carbon already had 4 valence electrons of its own. And by sharing, each hydrogen has a pair, has 2, hydrogen is happy, and now the carbon in the middle has 2, 4, 6, 8, it is happy. Whenever there is a shared pair of valence electrons, we refer to that as a covalent bond. So you can see that in this molecule, this distinct unit of bonded atoms right here, this molecule, there are 1, 2, 3, 4 shared pairs. 1, 2, 3, 4 covalent bonds. This diagram, this way of representing covalent bonds by actually showing the valence electrons, it's known as a Lewis structure. The Lewis structure shows the valence electrons, only the valence electrons, the outermost electrons of elements, and how they get shared in covalent structures in molecules. And you must be able to recognize and draw Lewis structures for this course. Here's what a Lewis structure would look like for water. This is a little bit more detail than you would need. I'll show you how to do it simpler in a little bit. Water is H2O. That means that a single water molecule actually has 2 hydrogens and 1 oxygen. I know it's covalent because these are both nonmetals. Covalent compounds occur between nonmetals. I know they're going to share their valence electrons so that all atoms in the system are stable, have reached an octet, or in hydrogen's case gets 2. So here's hydrogen bringing its single valence electron. Here's another hydrogen bringing its single valence electron. And here's a single oxygen atom. And it has 1, 2, 3, 4, 5, 6 valence electrons. So if they begin to share, hydrogen will be very happy because it now has 2 valence electrons. This hydrogen is also very happy because it now has 2. Oxygen is also happy and stable and has reached a potential energy minimum because it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So by sharing, they have all reached their octet. Hydrogen has reached its duet, I suppose you could say. It's 2 valence electrons. Yay.